Well, thank you for inviting me. I'm really happy to be here. I want to apologize right ahead about the presentation. We had some technical problems, so the background doesn't look very well and you cannot read properly, but there will be a copy available of the presentation. I'm going to leave it with Jennifer, so if anybody wants a copy, just please ask her. So today I'm going to be talking about a number of studies that we did on orchard ground management systems in New York. They're not exclusively organic, but it's a good comparison of 4 different ground cover management systems, 2 of them being very conventional and 2 of them that can be applicable to an organic situation. So take that in account as we go through the presentation. So what I'll be talking about is basically what's the effects of these long-term studies on orchard ground cover management system on the tree physiology and the yields, the soil physical, chemical, and biological conditions, the nutrient dynamics, and the agrochemical leaching and runoff. So the first study, it's a study that started in 1991 in New York State in an apple orchard. The objective of the study was to see what are the impacts of different ground management systems on the tree growth, the nutrition, the production, and a number of other aspects in the physical condition and chemical and edaphic conditions of the soil over 17 years. So usually when we see this kind of study, or study that there are 5 years, the most 8 years, but it's very interesting to see a study like this for like 16 or 17 years in which we were very surprised with the results. So we had 4 treatments. This was an orchard, as I said, established in 1991. The root stocks were M9 and the variety was Empire. We had 4 different treatments. A pre-emergent herbicide that was a mix of different soil-active herbicides like Duron and Norfolceran and glyphosate. We had a post-emergent treatment that was just glyphosate. We would apply it twice a year during the growing season in May and in July. Then we had a soil treatment that was at the very beginning, just a red fescue that evolved into a mix of different broadleaves. During the years, we only seeded once, and afterwards we just let it grow. And then the 4th treatment was a bark mulch. It was around 15 centimeters we applied, and that's more or less 25 cubic yards per acre of this hardwood bark mulch. So when we look at what happened during these 17 years on the tree growth, you can see at the very beginning, I'm just so sorry that, maybe I can take this. There. I'm just going to focus here, if everybody can see here. Okay. So if you see the very first years, you see some significant difference on the trees that were the first 2 were the trees with the herbicide treatment. They are slightly bigger, and that trend kind of carried on until, I would say, the 5th year, in which the trees in the herbicide treatment were bigger, and that's what we would expect. But then as we move on, we start seeing that the trees in the mulch treatment start to pick up and start growing, and they're much bigger than the trees that were established in either the herbicide treatments or the sod treatment. And you see that the last years, here the column in black, the mulch trees had a significantly higher trunk diameter or trunk cross-sectional area than the trees on the other treatments. In 1998, there was 1 tree that was excavated, and what we did is we separated the different parts of the tree, the above ground and the below ground, and we dried them and weighed them to see how different were the trees, the different parts, the main trunk and the root systems, and also the different woods from different years. So when we look at the below ground and we look at what happened with the root system, we only saw significant difference in the secondary roots, so the roots that are between 1 millimeter to 1 centimeter of diameter. So in the treatment on mulch and the post-emergence herbicide, that's only the glyphosate, we saw that we had a higher number and we had a higher dry matter of secondary roots. But all of the rest, we really didn't see any significant difference in any of the other aspects we evaluated, and we measured all the trees were significantly the same. Even though you see difference in the bar, there was no statistical differences. When we look at the fruit yield, and it's very interesting, we see again that during the first years of bearing fruit, these first two columns that represent the herbicide treatment had a higher yield than the sod treatment and the mulch treatment. But then as we keep on moving forward to time, we don't really see much of a difference. And that was very interesting, given that most of these kind of studies, as I say, they're only 5 to 6 years, and they tend to show that trees that are under herbicide treatment, they grow more and they produce more. But if you go after those maybe 5 initial years, you look at this, and that is actually not true. That's not what happened. And so we had a couple of years when you see very low yield. That's because we had spring frost. So when you look at the effects of the treatments on the soil, there's a lot of data, but I just want to highlight it. After 17 years, the treatments, the soil of the treatments under the mulch tend to have higher phosphorus and also higher calcium, and they also had higher manganese. And there were other statistical differences, like for example, the available nitrate was also higher under the mulch, and the pH was higher under the mulch as well. When we look at the percent of total nitrogen, carbon, and the carbon to nitrogen ratio in the soil, we see something, it's very stable during time. We see that the nitrogen and the carbon in the soil are much, much higher than on the other treatments, and that was significant for all the years that we measured, and so was this ratio of carbon to nitrogen. This is a study from Shenri Yao. It's another scientist that worked in the same lab as I did, and what she did is she looked at the microbial activity of these soils. So she took samples and she looked at, well, how much microbial activity do we have? And what she did is she measured the respiration of the soil, which is an indicator of how much microbial population do we have and how active they are. And what you see here is that under the mulch, we have a much, much higher respiration and much higher activity. And here what she did, she counted the colonies of bacteria and fungi, and she saw also that in the herbicides, especially the pre-emergence herbicides, they tend to have a lower bacteria and fungi forming colonies. Oliveira, in the same study, he looked at some physical characteristics of the soil, the bulk density, the porosity, the saturation, the infiltration rate, the soil water content. And one of the things that he saw is that the treatments in mulch, in general, had a significantly lower bulk density, so the soil was less compacted than on the other treatments. And that something that I want you to keep in mind as I'll show some data on runoff and on leachate. And the porosity was also higher in the mulch. And he saw some difference in the saturated viral conductivity and also the infiltrated rate, in which it was lower in the mulch treatment. And I'm sorry about this is the problem that I had, but I just want to read some final conclusions of this 16-year study. So in general, we saw that the soil nitrogen, the carbon, and the carbon to nitrogen ratios of the soil were much higher in the mulch than in the other treatments. We also saw that there was a deterioration of the physical conditions and the biological activity and the soil fertility in the weed-free plots, the 2 herbicide plots, and the post-emergent herbicide reduced the weed competition during the summer. I said that we applied this glyphosate in May and July. It seemed to be a good combination for tree growth during the initial years, but also for the soil conservation. So now what I will be presenting is a second study of the same plot and the same treatments, and it's about the nutrient cyclings in this orchard. How, in a specific case of nitrogen, how nitrogen works in the orchard. What happens when you have different soil management? Do we have more nitrogen in the soil? Do we have the trees absorbing more nitrogen? Do we have more decomposition of, for example, the leaves and the residues of the pruning? Do they decompose faster, or do it takes longer depending on what treatments do you have in the soil? And does that help the different treatments produce more or less fruit? So depending on the different soil treatments that you have, we wanted to see the different components of nitrogen and how do they work in the entire system of an apple orchard. So as I said, what we did a budget to look at all of the inputs and all of the outputs of nitrogen and all of those components in which the nitrogen actually stays in the orchard. Like, for example, when all of the leaves fall, those leaves decompose on the floor of your orchard, and what happens with the nitrogen that is on those leaves? Where does it go? And we did it in 2 years. In 1 year, we applied fertilizer. We applied around 53 pounds per acre of nitrogen. And then 2 years after, we did exactly the same budget, but without fertilization. So just work with the amount of nitrogens that were in the soil without having an input of nitrogen from fertilization. So we built this budget for 2 different years. So how do we do it? We measure the inputs of nitrogen, and we consider as input the nitrogen that was coming from the fertilizer, the nitrogen that was coming from the irrigation, and the precipitation that naturally has nitrogen, how much nitrogen we were putting just by the water of the irrigation and was coming from the precipitation from atmospheric deposition. And we also consider the amount of nitrogen that was in the mulch, because that mulch was made out of wood, and that wood, of course, has nitrogen. So we consider the amount of nitrogen that was coming from that mulch as an input, as an external input of nitrogen. What did we consider as internal fluxes? Well, everything that is recycling of the surface vegetation. So what we did here is we collected all of the vegetation, above ground vegetation that we could find in the ground of the apple orchard. We collected some fruits that were left, that dropped. We collected some of the weeds that were there, and we put all of those into little bags. And what we did is we measured the amount of nitrogen that was originally in this mix of litter. So we say, okay, we have, let's say a number, 100 grams of nitrogen there. And then a couple of weeks afterwards, we took a sample of what was in that bag, and we say, oh, we only have 80 grams of nitrogen. It means that there were 20 that were released, and they were going into the orchard soil, and probably the trees absorbing. So that's how we measure all of the nitrogen that was being recycled from either the leaves or the leftovers of the pruning and the fruit that drops. Then we measure all of the leaf litter. What we did, we just wrap a big tree. We wrap one of the trees into a big bird nest, and we capture all of the leaves. We measure, we weigh them all, and we took a sample, and we took a sample of nitrogen and how much nitrogen was in there, and we back calculated for all of the leaves of a tree, and that's how we measure how much nitrogen was being recycled from all of the leaves. And then, of course, we also took a sample of the prune wood, how much nitrogen was in the prune wood, and how much nitrogen was coming from the soil. Because the soil has organic matter, and that organic matter is constantly mineralizing and releasing nitrogen that the trees are going to absorb. What did we measure as an output? We measured all the fruit of the trees. We captured all of them, we weighed them, we took a sample of how much nitrogen was there, and we measured the nitrogen taken out by the fruit that we actually completely taking out of the orchard. That fruit is out of the orchard, so that nitrogen is not coming back. And we also measured the amount of nitrogen that was being leached through the soil profile, and that was going out of the orchard. And for that, what we did is each one of these plots in which we had our treatment was hydrologically isolated, and we had a drainage line. We did this when the experiment was established. It was a drainage line that was probably like 3 to 4 feet deep that collected all the water from that plot, and it would drain all the water into underground water station in which we measured all of the water that was moving through that area, in this case, if you see here, all of the water that was infiltrated in this area was captured by this line, and then we would drain it into one of these stations, and we would measure the entire volume of water that was moving through the soil profile. So here we have how we measured it. So we had these sleeping buckets in which we had the water coming, and they would measure the volume of water, and we would take samples every time we had either a precipitation event or we have an irrigation event, and we would take a sample and measure the amount of nitrogen, and then just calculate how much nitrogen was leaving the orchard through this water that was draining and percolated through the soil profile. We did something very similar for the surface runoff. We had this pipe here that was capturing all the water that was running off from these plots. This is the mulch treatment, and then we had another station that would do exactly the same, measure the volume of water moving, and then we would take samples for nitrogen. So what did we see? Well, we looked at the decomposition of these bags with the above ground vegetation growing. We saw that in 2005, that was a year that we applied the 53 pounds of nitrogen per acre. We saw that there was a much, much higher release of nitrogen from this above ground vegetation growing in the orchard, in the different treatments, of course. And in the year 2007, there was a year there was no nitrogen fertilization. It was much lower. But in both years, we saw that it was the mulch treatment that released the biggest amount of nitrogen. And this nitrogen, as I said, was just being recycled and staying in the orchard. When we look at the nitrogen concentration in the runoff and the leachate samples, in the runoff samples, we saw in 2005 that the pre-emergence herbicides, the soil active herbicide, was bare soil, we didn't have anything. We had the higher concentration of nitrogen on the runoff. So all of the amount of water that was running off from these plots that didn't have any vegetation, that were bare soil, had a really high, had the highest concentration of nitrogen. And as you recall of some of the tables that I showed before of the soil characteristic of these soils these plots that had bare soil, the soil was very compacted. So that's why we assumed that one, we had higher volumes and also higher concentration of nitrogen that was just leaving the orchard. And in terms of leachate, we saw that the highest amount of leachates that the lowest amount of leachates was coming from the pre-herb, just because there was less infiltration, there was less water penetrating that soil, because we saw that there was a crust that formed on the upper part of the soil, just because it was bare and exposed to all of these erosion agents. In terms of the water flow, the amount of water, we saw that mulch had the lowest runoff, but the highest volume of leachate. So the water was not running off the surface, it was just infiltrated, and since we had such a nice porosity and fluffy soil, the water would just run through the profile. So when we constructed these budgets, I know there's a lot of data, but I'm just going to guide you through. The first part is all of the external inputs, the fertilization and the amount of nitrogen that was coming from the mulch biomass and the water from the rain and the irrigation. We see that the mulch treatment in both years had a higher amount of input just because all of the nitrogen that is coming from the mulch itself. When we look at the internal fluxes, one of the things that was very surprising is that the mulch treatment and the sod treatment had much higher nitrogen recycling pools. So there was a lot of nitrogen in those two treatments, in the sod and in the mulch, that was just being recycled and stayed there. There was constantly an amount of nitrogen that never left the orchard. And in terms of the balance, if we add the inputs and the internal fluxes and we subtract everything that was going out of the orchard, everything that was going out through the runoff water and everything that was going out through the surface, through the leachate, we have that the sod treatment and the mulch treatment in the year without fertilizer, that's 2007, had positive balance, meaning that they didn't need extra fertilization. After 17 years, the system was so stable that even when you don't put extra nitrogen, there's enough nitrogen for the trees to produce fruit and produce high-quality fruit and for the trees to grow. So after 17 years, both of those treatments, the sod and the mulch treatment, were very stable treatments in terms of nitrogen. So just some final conclusion. The soil nitrogen mineralization and the recycling of the biomass that was above ground, growing above ground in all of this treatment, accounted for 60% of all of the internal fluxes of nitrogen. So the soil mineralization and the above ground biomass was 60% of the nitrogen in the entire orchard and was staying in the orchard and was constantly being recycled. The harvested fruit for all of the treatment was more than 70% of the nitrogen output. So 70% of the nitrogen that was put into that orchard went out with the fruit. Most of the nitrogen losses occur through the leachate rather than through runoff, regardless of the treatment of whether it was herbicide, mulch, or sod, which was very interesting because, at least in New York, we were very concerned with nitrogen contamination water, especially because we are close. This was in Ithaca, New York. We were very close to a big lake, so there's a lot of contamination through nitrogen and phosphorus as well. So that was. We were very surprised with that result. As I said, there were positive bounds of nitrogen in the sod and in the mulch. In both treatments, they were very stable and they didn't need extra nitrogen. And as I said, one of the potential long-term problems is the amount of nitrogen that is coming out through the leachate from this orchard. And that's why we recommend the growers that had this treatment and they were applying a lot of mulch to just try to space those applications of mulch during time. They used to do it every 2 years. We said, well, why don't we start spacing every 5 years, because we are putting too much nitrogen that is coming from the mulch, which is surprising because most of the growers wouldn't think that that's the case that is happening, that we're putting too much nitrogen because we're putting too much mulch, but that's one of the beauties of the study. That's a long-term study that shows that after 17 years in which you're putting more nitrogen, it actually starts to build up in the soil. Different conditions from Utah, of course. In New York, we have much higher precipitation, and we tend to be able to build organic matter in the soils much easier than what happens here. So that's something to keep in mind when you try to extrapolate all of these data into the context of Utah. And the nitrogen deficit in both herbicides, when the year that we didn't have any nitrogen input, and that is because the difference between the two herbicide treatments with the sod and the mulch is that the amount of nitrogen that was being recycled and stayed in the orchard was much lower. So we needed to put extra nitrogen because we were not recycling and we were losing it. And that's the case with the two herbicide treatments.